Hi, this is Mr. Warnow here. I'm going to go over the last quiz. Since some of you guys had trouble with it, I thought I might go over this with you to help you prepare for the test. So let's take a look at number 1. Now, the first thing to remember is not everything is U-substitution. Sure, the x is inside of a square root, but it doesn't mean it's U-substitution because I could just rewrite this x as just the square root of x, or x to the 1/2. And I can integrate this. This becomes x cubed over 3 plus x to the 3/2 times 2/3. And we will evaluate that from 0 to 1. Excuse me. So when we use the fundamental theorem, FTC, we go f of 1 minus f of 0. And plugging it in, don't forget your parentheses, it does help. Plugging in the 1, here we get 1/3. Plus, plugging the 1 here, we get 2/3. Because 1 to the 3/2 is just 1. And plugging the 0, we just get 0 plus 0. You can leave your answer as this, which is fine, or just reduce that to 1. Now, same thing. This is 1 plus cosine of x. Now, some of you guys were writing that 1 plus cosine of x is sine of x. Well, that is no trig identity you learned last year. The one you're thinking about is if I have something like 1 minus cosine squared of x is sine squared of x. That's not close to that because 1, there's nothing squared and there's no minus, so we're not using a Pythagorean identity for this one. We're just going to take the antiderivative. Well, the antiderivative of 1 is just x. The antiderivative of cosine, well, I'm thinking what function's derivative is cosine of x, and we know that that's sine of x. So this is just plus sine of x. And again, we're going to evaluate that from 0 to pi. So plugging it in, f of pi minus f of 0. Using the fundamental theorem, plug those in. We get pi plus, now the sine of pi is 0. Plug in 0, 0. The sine of 0, also 0. So here, again, you can leave it like this, or just simplify that down to just pi. Very easy to do. Now down here we get to the U-substitution problem. So let's take a look here real quickly. Oops, sorry, let me refocus. Let me redo the focus. When we solve a question like number 3 here, doing the U-substitution, this is inside, so we're going to let u equal x to the 4th plus 9. du is 4x cubed dx. So I get this dx equals du over 4x cubed. I'm not worried about anything else, just taking the antiderivative. X cubed over u to the 1/2 du over 4x cubed. Now notice I didn't rewrite the domain because we're about to change that. But I should notice that the x cubes cancel. Factoring out the 1/4, we get u to the negative 1/2 du. And now I'm going to take a look at my domain. Remember, this is U-substitution. Here, x is negative 1. Well, I want to say, well, if x is negative 1, how do I get u? Well, u is negative 1 squared plus 9, which is 10. So I put that down here. Next, I let x equal 0. Well, if x is 0, u is 0 squared plus 9, or u is 9. So I go to 9. Change your domain. Now I can integrate this. I get 1/2. This becomes u to the 1/2 times 2. And I'm going to evaluate that from 10 to 9. Don't switch those. Okay? We always said, oh, the lower one was on bottom. But remember, the original, the lower one was on bottom. We're just substituting in for that. And if I solve this, f of 9 minus f of 10. Plugging in 9, this becomes 1/2. That becomes the square root of 9. 9 to the 1/2. Minus 1/2. Plug in the 10. The square root of 10. Now where do I get the 1/2 from? Well, that's 1/4 times 2. And I can leave it like that. That's okay. But we should never leave the square root of 9. That's just 3/2 minus root 10 over 2. And there's our answer right here. Question number 4. This is a little... excuse me. This is a little tougher problem right here, because if you notice for number 4, it's not as easy to pick the inside. We want to think secant because of the square, but we want to think of the derivatives. Well, I know that the derivative of tangent x is secant squared of x. So this will be my u. U is tangent of x, the derivative, secant squared of x, dx. So dx equals du over secant squared of x. So when I rewrite this, again, I'm not going to worry about the domains. I get u times the secant squared of x, du over the secant squared of x. And those cancel. And what am I left with? U du. At this time, I will change my domain. Now, the reason I change my domain is so that I don't have to plug my u back in at the end. So when x is 0, u is the tangent of 0, which is 0. When x is pi over 4, u is the tangent of pi over 4, which is 1. And now I just use my fundamental theorem. I integrate, I get u squared over 2. We're in terms of u, so again, I don't have to put my u back in. Now, if I left this as 0 and pi over 4, I would put my u back in. But I changed my domain. So plug in the FTC. We're going to get, this becomes 1/2 minus 0, or just 1/2. Very easy to do. Now, this whole page took me about 6 minutes. So, and that's going kind of slow. You can go faster with this, but you have to get the practice at home. So let's take a look at the second part. There we go. Give it a second to focus here. All right. Question number 5. Question number 5 is an algebraic substitution. And I know that because I'm going to try u sub here. Let u equal x plus 1. My du is just dx. So I'm going to rewrite this as x times u to the 1/2 du. Now, I cannot integrate this because I have u and x in the same problem. So what we're going to do instead is we're going to use what's called an algebraic substitution. What that means, well, I know u is x plus 1, so if u is x plus 1, x has to be u minus 1. And I can just substitute that in, and I'm going to do that over here. This becomes, instead of x, u minus 1, u to the 1/2 du. Now, be very careful. We cannot integrate this as is right now. The way it looks right now, we cannot integrate it. So what we have to do, be very careful, we have to distribute. What we have to do here is distribute. So when we distribute, we get u to the 3/2 minus u to the 1/2 du. And integrate. Now I can integrate. Now some of you guys are like, Mr. Warnow, can we simplify this? Can we write this as just u to the 3/2 minus u to the 1/2 as just u to the 2/2? Combine those. You can't combine them. You have to integrate. If anything else, my rule for simplifying is don't be a hero. I integrate now. Minus u to the 3/2 times 2/3 plus c1. That's my antiderivative. All I have to do now is replace u. And we get the following. 5/2, u we said was x plus 1, to the 5/2. Whoops, sorry. That should be 2/5. I'm sorry about that. That should be 2/5 because we had to flip it. Sorry about that. You probably already caught that mistake. Minus 2/3, and again, x plus 1 to the 3/2 plus c1. And there's our answer right there. Very easy to do. Alright, so now we have this word problem I do. Now this is an AP question. This is how the AP is going to ask us these type of questions. So if we take a look right here, we want to answer the following. And they give us the temperature. Remember, notice the units that they're giving us. If you understand units, these are pretty easy. It says the temperature of water in the tub is modeled above, where WT is measured in degrees Fahrenheit. We want to estimate W prime of 12. Well, they didn't give me W prime, the derivative. They want me to find a derivative here, which for us, remember, means slope. Look at it. This is a note I write to myself on my test or quiz. Heck, it's for me. I don't care if the teacher sees it. I'm not going to show anybody else. So I want to find the slope at 12. Well, they don't give me the slopes, and they don't give me 12. So how do I solve it? A-rock. W prime of 12 is about, it's between 15 and 9, so it's going to be about W 15 minus W of 9 over 15 minus 9. So what's that? 67.9 minus 61.8 over 6. And I'm going to get my ever trusty calculator here to do the nasty work for me. And if I take the, doc B that thing, so if I take that 67.9 minus 61.8, I get 6.1 over 6. If I divide that by 6, whoops, okay, sorry, man, that happens. So 6.1 divided by 6, we get 1.017 roughly. So then it says, use correct units, interpret the meaning. Well, W, remember, look at the units. My A-rock, ready? My top is being measured in degrees. Let me take a look here. My top is degrees Fahrenheit. This is in minutes. So this is going to be degrees Fahrenheit per minute. So what is it saying? At 12 minutes, the temperature is increasing at a rate of 1.017 degrees Fahrenheit per minute. Something along those lines. All right, now the next one. This is just straightforward FTC. Now notice, FTC, they gave us W prime. But what we're looking for, what they gave us is W. This should be a no-brainer. W prime of t dt, you're given one of these, you're like, thank you. W of 20 minus W of 0. Plugging that in at 20. It says this is just FTC. At 20, the value is 71. At 0, the value is 55. So that's 16 degrees Fahrenheit. So what does it mean in terms of the problem? It says that the temperature increased by 16 degrees Fahrenheit over the 20 minutes. And that's what we would write. Something along those lines. Now the next one says the average temperature can be modeled by this. Right here, average temperature can be modeled by this. Use a left remove sum, which means I have to find the area at one point. So if I want to find 1/20th of 0 to 20, W of t dt, well, the first part is the hard part, this integral. I have to find the area. And they tell me how to do that. I'm going to make rectangles. 0, 4, 9, 15, 20. Using a left Riemann sum, 0 is on the left, so it's going to have a height of 55. At 4, a height of 57.1. At 9, it has a height of 61.8. And at 15, 67.9. And I'm going to find the area there. So to get the area from 0 to 20, WT dt, they're telling me use a rectangle. The first one is 55 by 4 plus the next one, be careful, 57.1 by 5 plus the next one, 61.8 by 6. And then the last one, it's 67.9 by 5. And I'm just going to add them all up in my calculator. Can my calculator do the work? 55 times 4 plus 57.1 by 5 plus 61.8 by 6 plus 67.9 by 5. And I get this 1,215.8. Now that's not the answer, because I want average temperature. This isn't Houston temperature right here. We want normal temperature. So we're going to take that 1 over 20 and multiply that by it. So if I multiply by 1 over 20, or divide by 20, I guess, we get a nice calm 60.79 degrees Fahrenheit. Much cooler for a bathtub. You don't want to step in a bathtub at that temperature. That could hurt. So this isn't taking long. So far I'm on about 14 minutes right now. Now for the last one, this is an easy one. Again, they're giving us a rate of change. In other words, they're giving us the derivative, if we read the problem here. The function models the water temperature rate is given by this formula. Based on this model and the fact that W of 20 is 71, so they're giving me some initial value, so I know I'm going to have to solve something. What is the temperature of the water? So they give me the derivative, I have to find the value. We know we have to integrate here. This is an integral. We have to we're going to integrate. This is just a straightforward FTC. I put my W prime of t dt. Now, I'm starting at 20 and I'm going to 25 minutes. Well, this is going to equal the temperature at 25 minutes minus the temperature at 20 minutes. Now, let me just go over this again. This integral right here, if I type this in my calculator, what's that going to give me? Look at the units. W prime of t, it's a rate of temperature. This is degrees Fahrenheit per minute. dt is minutes. Those cancel. So it's going to give me my change in temperature. This is my change in temperature. So I'm just going to type that in my calculator. Turn my calculator on. There. Ready? Menu 42. I just type it in. From 20 to 25. 0.4 square root of x, or sorry, you can use t if you want to even. Look, t, I can use t times cosine of 0.06 t. Just remember, you put the t on the outside here. T. I just press enter, and I get this 2.04. So we're saying that the temperature of the water in those 5 minutes increased by 2.04315 degrees Fahrenheit, equaling W25, which is what I want, minus the initial temperature, which is 71. So the water is getting hotter. So therefore, to solve for it, I add 71, so I go plus 71, and I get to 73 degrees right here. See like that? I get 73 degrees. And I'm going to write down my answer. 73.0432 degrees Fahrenheit. All these and more are on your test. You have to know how to do this. Please study for this, okay? I encourage you guys, come in for tutorials more, okay? You guys can do this, I promise.